Okay, so this was what I've been invited to talk about today. David being, as always, a hard act to follow. Let's try it. The areas I want to talk about are briefly on the anthropogenic greenhouse effect that David has talked about, more in terms of how it will play out in the future. Characteristics of the carbon cycle, which is my core area of expertise, and why the properties of the carbon cycle really make the challenge of climate mitigation very hard. Some of the numbers on what it would actually take to stabilise atmospheric CO2, and a little bit on national targets. And then, if I have time, talk a little bit about the feedbacks that David mentioned, because in spite of what you would see in the media about what I call a pretend debate between the deniers and, say, the IPCC views, there is a real scientific debate, and I'll talk a little bit about where the exciting science actually is, where real scientific debates are happening. I don't know how readable this is. This is actually from the previous 2001 IPCC assessment, showing how the sort of things David talked about will play out into the future over this century. Starting from CO2 emissions, we don't have a up in the. Oh, got it. Okay, up on this panel we have various ranges of possible CO2 emissions for various socio-economic pathways. A lot of people criticise the IPCC for presenting their work in this way, but in practice, this is saying these are the types of policy choices that are available. Some of them may be unrealistic. That's for the policy makers to decide which of them they can, might, or want to try and follow. It's, I think, not a job for climate scientists to go and prescribe them such choices, and this is certainly the view the IPCC has taken for a range of reasons. What this translates to in terms of CO2 concentrations over this century, if you cut down emissions a lot, you do end up with relatively low, small increases. The sulfate component, as David said, you need all the forcing agents if you're going to get this sort of calculation correct. So that's the sulfur dioxide emissions that are the primary influence on sulfate aerosols. Out of that you come temperature changes. There are real ranges of uncertainties here, and I'll talk about that a little more in a minute. So the time you combine the uncertainties of the climate models with the various ranges of possible emissions, that you end up with quite a range on temperature, and you then track that through to sea level rise. So that is what really where the concern comes from. I've tried to capture this in terms of amounts of warming over this century as a spectrum. And down the bottom we have the denial view, that there'll be no greenhouse warming, that the Earth is cooling, even been cooling since 1998. We've seen the pictures. We get it in editorials in the Australian. People who downplay it a bit and say, yeah, 1 degree is not too bad, probably be good for us. The medieval warming was a great time, prosperous in England at least, and so on. You get up into the low end of the IPCC where things are all happening nice and smoothly. And within the range of scientific uncertainties, you then start worrying about some of these feedback effects David mentioned briefly, and I'll talk about some more, or the more worrying things about instabilities of the Greenland ice sheet, or a combination of worst cases can take you up to that sort of number. And beyond that, you start to get in, this is a personal assessment, I'm not going to defend to the death every line I've drawn here. You get into the alarmism range, shutdown of the Gulf Stream, billions of people will die from climate change, as Philip Adams has said in the Australian magazine a few times. But my view is the real and interesting scientific debate is within this range here, which is a big range. There's lots of good science to be done. It's one of the things that keeps me working. In terms of stabilising CO2, again, these are old numbers out of the IPCC. Just doing this step that I showed earlier, going from emissions to concentrations. These numbers A1, A1B, B1 were two of that set of IPCC scenarios that were there earlier. They only track through to 2100. So the concentrations are likewise only tracked through. If you say, what would we actually take to get concentrations to become constant some century or two out in the future, at whether it's at 1,000 ppm compared to the 380 we are now, or what's the other one, 750, 650, 550, or maybe 560 and 450, typical numbers people talk about. The 561 gets a fair amount of attention because it's double what the levels were pre-industrially. You find that the type of emissions you need have to vary, after a little bit of chance to peak, have to drop off very rapidly. And that is where the real difficulty in managing CO2 comes from. This need for a very rapid drop-off. Some of the reasons for it are also encapsulated, yet another IPCC slide, in terms of how the different timescales of the climate system relate. What was really showing before was to stabilise CO2 concentrations, you have to have a set of emissions that can peak, get a little bit higher, but then have to drop off rapidly. And I'll have specific numbers on that later on, but that's the schematic picture of what it looks like. If you do that, what you'll find is temperature keeps on increasing a little bit afterwards and slowly increasing for quite a while after that. But stabilising greenhouse gas concentrations does not instantly stabilise temperature. There's a term phrase for this, it's called committed warming. And when people talk about committed warming, that's what they mean, the fact that stabilising greenhouse gas concentrations will not instantly stabilise temperature. It certainly doesn't instantly stabilise the effect of the heat on the oceans, because heat takes a long time to get down into the ocean. Everything takes a long time to get into the deep ocean. CO2 takes a long time to get into the deep ocean. That's why effectively these curves are the shape they are, because the oceans can take up quite a lot of carbon dioxide if you give them enough time to do it. But if you hit it very rapidly, as we are now, then it's going to take a long time to come into a balanced situation.